Hey, my name is Wael Halbawi and I'm an electrical engineering senior at Texas A&M at Qatar. I spent the summer of 2010 working with Dr. Huff in the electromagnetics lab. We analyzed radio frequency propagation in Education City in Doha, Qatar. Right now, I will walk you through some of the results we obtained from our work over the summer. So the motivation of the real work was to actually find or come up with a radio frequency propagation model for the state of Qatar. As you can see in the pictures, the environment is very complex, ranging from high-rise skyscrapers to plain desert. The work is a collaboration between QTEL, the leading telecom provider in the country, and Texas A&M University at Qatar, specifically the Wireless Research Lab. In our experimental setup, we're using an agent signal generator that's hooked up to an omnidirectional antenna, as seen on the slides. And all of this was mounted onto the rooftop of the Texas A&M Engineering Building in Education City. On the receiver side, we have a network analyzer, again connected to a quarter wavelength monopole antenna, and then the data is being processed using a laptop. The equipment is placed in a vehicle with the antenna mounted on the rooftop. Wireless Insight is a sophisticated software package that deals with simulating and analyzing electromagnetic waves. It is developed by Remcom, and basically it incorporates many features, most of which we can see in the current picture. Using the software, we can build different models of cities or buildings and then place our different receivers and transmitters, run a simulation, and then obtain different results graphically and numerically. These are a few of the buildings that are present in Education City at the moment. As you can see, they are very different, so we try to model them as accurately as possible using Wireless Insight. Over here is a map of Education City as captured from Google Earth. We modeled the different buildings shown earlier in addition to other ones. And then the colored line is the drive route actually taken when recording our measurements. It is color-coded according to the legend shown in the bottom of the picture, and that the colors represent received power. In the frame at the top left are a few propagation paths that are exiting a transmitter and then are being sensed by different receiver points. On this slide, we have two snapshots of close-ups to the model built. On the left is the Texas A&M Engineering Building with the height amplified, so it provides better visual aid. And on the right, we have different buildings of the housing complex, with propagation paths snaking through the buildings and then terminating at the reception point. We can also see on the picture on the right a portion of the drive route, again color-coded according to received power. Now these are some plots of the measured data. They represent different quantities. On the left, we have the probability density function of the received power. It's a bimodal distribution. On the right, we have an expected classic power versus distance plot. As we can see, the power is decreasing as we increase distance. And then on the bottom right, we have a path loss versus distance graph in which the data was fitted using mathematical software, and the equation produced is shown on the left. The graphs on this slide are basically the same representation of the measured data, but for the simulated data, we can see that they are very close to our real results, showing that the software provides a very good simulation model. And then lastly, to compare the received power statistically, we calculated a correlation coefficient using the received power quantities in dBm. We can see that we have a high correlation coefficient of 0.78, which shows that the the two different quantities are close to each other quite enough. Once again, my name is Wael Halbawi, and I would like to thank you for listening to my presentation. I would also like to thank Dr. Greg Huff and Dr. Khaled Karaki for giving me the opportunity to work with them. Thank you.